Let us look at the break-even analysis using graphical method. On your screen, you can see a graph with units sold on the x-axis and the dollar amount on the y-axis. Now we know that there are three main components involved in the break-even analysis. The first one is fixed cost. Second is the variable cost. And the third is revenue. So let us understand how we can plot these three on this graph. Let us first take the fixed cost. Now we know that by definition, fixed cost is the cost which does not vary by the volume of production. So irrespective of the number of units sold, the fixed cost will remain constant. So on the graph, if we have to plot the line, basically the cost will be the same if the number of units sold is 10, 20, 30, 40, 50 or 60. So what this gives us is a straight line parallel to the x-axis. So let us draw that line. So let's say that the fixed cost is $2,000. So the line representing the fixed cost will be starting from $2,000 and parallel to the x-axis. So this line here represents the fixed cost. So what this line means is that the fixed cost is $2,000 whether the number of units sold is 5, 10, 15, 20 up to any other number of units sold. Now let's move to variable cost. So variable cost varies by the number of units sold. So if we have to plot the variable cost, so let's say this is the graph with units sold on the x-axis and dollar amount on the y-axis. Now if we don't produce anything, that is if we have number of units as 0, then there is no cost. So there is no cost because we are not producing anything. So the line for variable cost will start from here and it will go like this. This will be representing the variable cost. The slope of this line will depend on the cost per unit. Now again, on this graph, the fixed cost will be a line like this. So this will represent the fixed cost. Now if we add the two, the variable cost and the fixed cost, then we get the total cost. So if we have to draw the line for total cost on this graph, basically at this point when the number of units sold is 0, the variable cost is also 0 while there is a certain amount of fixed cost. So the total cost will start from here and will go like this. So this line will represent the total cost. And basically on this total cost line at any point, let's say this point, the total cost is the addition of the variable cost and the fixed cost at that number of units sold. So let's use this concept to draw the line for total cost on this main graph. So as mentioned earlier, since the variable cost at 0 units is 0, however fixed cost is 2000, so the total cost will start from 2000, and then as we keep on adding the variable cost to the fixed cost, we will get the line for our total cost. Now let's say that the variable cost is equal to $120 per unit. So at the point where number of units is 40, let's find out the total variable cost. So if quantity is equal to 40, the total variable cost is equal to 120 multiplied by 40. 12 fours are 48, so $4,800 is the variable cost at 40 units. So for drawing the line for total cost, we already have one point which is here at $2,000 intercepting at the y-axis, and the second point is at 40 units. The variable cost is 4,800, and if we add to this amount the fixed cost, so total cost will be equal to 4,800, which is the variable cost, plus fixed cost, which is 2,000. So this becomes $6,800. So the second point is 40 and 6,800. Let's say it is here somewhere. So with these 2 points, let's draw the line for total cost. So this line here represents the total cost. Now the third line which we have to draw is for revenue. Let's say that each unit is being sold at a selling price of $200 per unit. So selling price is $200 per unit. So at a point where 0 units are sold, the total revenue will be 0. Now let's find out the total revenue at a point where 40 units are sold. So the total revenue will be equal to 200 multiplied by 40, which is equal to 4 twos are 8, $1,000. So at 40 units sold, the total revenue will be equal to $8,000. So now we have 2 points. One is 0 and the other one is $8,000 and 40 units. So let's draw the line for total revenue. So let's say the point is somewhere here, 8,040. Now again, this graph is not at scale. So let's draw the line for total revenue. So this represents the total revenue. So on this graph, the point at which the total revenue is equal to the total cost is this point here, where both of them are intersecting each other, and this point is known as the break-even point. So this is the break-even point. Now if we draw a line parallel to the y-axis touching the x-axis, then the point here on the x-axis will represent the break-even point in terms of units sold, and if we draw a line parallel to the x-axis touching the y-axis like this, then this point here will represent the break-even point in terms of dollars. Now again, since this graph is not on scale, so these numbers may not be accurate, but these are representative of how you can actually achieve the break-even point using graphical method. Now this region here below the break-even point represents the area of loss, while this region here above the break-even point represents the area of profit. Now one question that comes to mind is that how do we know that these lines are linear or straight in nature? So let's take the example of the total cost line to understand this. Now we know that the total cost is equal to the fixed cost plus the variable cost, and the variable cost is equal to the number of units multiplied by the unit variable cost. So T is equal to F plus, let's say Q is the number of units and small c represents the unit variable cost. Now we know that the formula for a straight line is y is equal to mx plus c. Here c is a constant, that is a numerical value. M represents the slope of the line and x is the variable. So in this equation for a straight line, C is the point where the line intercepts on the y-axis. So now let's put the equation for total cost in terms of a straight line. So we get T is equal to CQ plus F. So here F is the constant or the y-intercept. So if we look at the graph, the total cost line intercepts the y-axis at a point which is equal to the fixed cost, which is in our case $2,000. So F is the y-intercept or the constant. Small c represents the slope. So basically the unit cost of the product determines the slope of the total cost line, and Q is the variable. Now let's do the same thing for the total revenue line. Now we know that total revenue is equal to the quantity of units sold multiplied by the unit selling price. Now the equation for a straight line is y is equal to mx plus c. So if we try to put the equation of total revenue in this terms, we get total revenue is equal to P multiplied by Q plus 0. Now as we know, C is the point at which the line intercepts the y-axis, and the total revenue line intercepts the y-axis at 0. So this is the constant in this case. P is the unit selling price, which represents the slope, and Q is the variable. So basically this proves that the total revenue line is also supposed to be a straight line as the total cost line.